Hey there, tech enthusiasts! Welcome back to our channel Cyberx Innovations. Today, we've got something super interesting to talk about: network topologies. But first, what on earth are network topologies? Well, it's like the secret recipe that makes the internet work. Think of it as the blueprint for how devices are connected. You see, every time you browse the web, play games online, or stream videos, your device is communicating with others over the internet. And it's these network topologies that decide how these connections are made. The arrangement of a network that comprises nodes and connecting lines via sender and receiver is referred to as network topology. The various network topologies are point-to-point topology, mesh topology, star topology, bus topology, ring topology, tree topology, hybrid topology. So let's start off by discussing how each of the network topologies function. Point-to-point topology. Point-to-point topology is a type of topology that works on the functionality of the sender and receiver. It is the simplest communication between two nodes, in which one is the sender and the other one is the receiver. Point-to-point provides high bandwidth. Mesh topology. In a mesh topology, every device is connected to another device via a particular channel. In mesh topology, the protocols used are AHCP, ad hoc configuration protocols, DHCP, dynamic host configuration protocol. It is like a complex web. Every device is connected to every other device. Super reliable, but it can be expensive and hard to set up. A mesh refers to rich interconnection among devices or nodes. Wireless mesh networks often consist of mesh clients, mesh routers, and gateways. Mobility of nodes is less frequent. If nodes constantly or frequently move, the mesh spends more time updating routes than delivering data. In a wireless mesh network, topology tends to be more static, so that routes computation can converge and delivery of data to their destinations can occur. Hence, this is a low-mobility centralized form of wireless ad hoc network. Also, because it sometimes relies on static nodes to act as gateways, it is not a truly all-wireless ad hoc network. In star topology, all the devices are connected to a single hub through a cable. This hub is the central node and all other nodes are connected to the central node. The hub can be passive in nature, not an intelligent hub such as broadcasting devices. At the same time, the hub can be intelligent, known as an active hub. Active hubs have repeaters in them. Coaxial cables or RJ45 cables are used to connect the computers. In star topology, many popular Ethernet LAN protocols are used as CD, collision detection, CSMA, carrier sense multiple access. A common example of star topology is a local area network, LAN, in an office where all computers are connected to a central hub. This topology is also used in wireless networks where all devices are connected to a wireless access point. Bus topology. Bus topology is a network type in which every computer and network device is connected to a single cable. It is bidirectional. It is a multi-point connection and a non-robust topology because if the backbone fails, the topology crashes. In bus topology, various MAC, media access control, protocols are followed by LAN Ethernet connections like TDMA, pure aloha, CDMA, slotted aloha, like a straight road, where all devices are connected to a single cable. Simple, but if the cable breaks, it's trouble. Ring topology is like a circular chain. Devices are connected in a loop. Data flows in one direction. Efficient, but if one device fails, it can disrupt the entire ring. In a ring topology, it forms a ring connecting devices with exactly two neighboring devices. A number of repeaters are used for ring topology with a large number of nodes, because if someone wants to send some data to the last node in the ring topology with 100 nodes, then the data will have to pass through 99 nodes to reach the 100th node. Hence, to prevent data loss, repeaters are used in the network. The data flows in one direction. It is unidirectional, but it can be made bidirectional by having two connections between each network node. It is called dual ring topology. In ring topology, the token ring passing protocol is used by the workstations to transmit the data. Tree topology. Tree topology is a topology which is having a tree structure in which all the computers are connected like the branches which are connected with the tree. This topology is the variation of the star topology. This topology has a hierarchical flow of data. In tree topology, protocols like DHCP and SAC, standard automatic configuration, are used. The various secondary hubs are connected to the central hub which contains the repeater. This data flow from top to bottom, i.e. from the central hub to the secondary and then to the devices, or from bottom to top, i.e. devices to the secondary hub and then to the central hub. It is a multi-point connection and a non-robust topology because if the backbone fails, the topology crashes. Hybrid topology. This topological technology is the combination of all the various types of topologies we have studied above. Hybrid topology is used when the nodes are free to take any form. It means these can be individuals such as ring or star topology, or can be a combination of various types of topologies seen above. Each individual topology uses the protocol that has been discussed earlier. Hybrid topologies combine two or more basic network topologies to create a more versatile and robust network infrastructure. By doing so, Organizations can tailor their networks to meet specific needs and balance factors like cost, scalability, and reliability. Hybrid topologies are commonly found in large-scale corporate networks, data centers, and critical infrastructure environments where both reliability and flexibility are paramount. You could also touch on the importance of network protocols in managing data transmission within these topologies. TCP/IP, for example, is the set of rules that ensures data is sent and received correctly across the Internet. Finally, it's worth mentioning that the choice of network topology depends on various factors, including the organization's needs, budget, and the level of redundancy and fault tolerance required. Different situations call for different network setups, and understanding these topologies helps in making informed decisions. And that wraps up our journey into the fascinating world of network topologies. We hope you've enjoyed this dive into the backbone of your Internet and how data travels around the world. Remember, whether it's the simplicity of a star, the resilience of a mesh, or the elegance of a hybrid, each topology has its place in the digital landscape, ensuring your online experiences are seamless and reliable. If you found